for Clinical Maths. So we've got the SQA Higher Maths 2025 Paper 2 full solutions here. Obviously, these are not SQA official solutions. These are just my own. These are actually probably copyrighted by SQA. But let's get into it straight away and we'll see how we got on this year. SQA Higher Maths 2025 Paper 2 Question 1. The triangle ABC has these vertices. Find the equation of the altitude, then the median, then the point of intersection. Fairly standard stuff here. Altitude through B, it says. So there's B there. So my altitude is at right angles to AC. So I need the gradient of AC. So for part A, the gradient of AC is minus 24 minus minus 14 all over 21 minus minus 9. Use a calculator anytime you want, but that is minus 24 plus 14 is minus 10 over 30, which is minus a third. So that means the gradient of our perpendicular is equal to 3 as m1, m2 equals minus 1. And then the point I'm using is B, which is 920. So y minus 20 equals 3x minus 9. Y minus 20, 3x minus 27 then. So y equals 3x minus 27 plus 20 is minus 7. And we're done there for part A. Part B, the equation of the median through A. So a median cuts the opposite side at, well, 50-50. So I need the midpoint of BC. So I've got 920. B is 920. And C, I think, was 21 minus 24. So the mid of BC, 9 plus 21 divided by 2, and 20 minus 24 divided by 2. 9 and 21 is 30, so that makes 15. 20 minus 24 is minus 4, so that makes minus 2. So we get 15 minus 2 as our midpoint. So now we need the gradient between A and M because we're needing to go from here to here, which is M. A is minus 9 minus 14. So the gradient between, let's call midpoint M, the gradient between A and M is y2 minus y1. So I'll just do minus 14 minus minus 2 over minus 9 minus 15. Minus 14 plus 2 is minus 12. And minus 9 minus 15 is minus 24, which leaves a half. So then use a point for A and B. I'll just use this one. Y minus minus 2 equals a half x minus 15. Take the 2 up then. Y plus 2 equals x minus 15. So we've got 2y plus 4 is x minus 15, or 2y minus x equals minus 19. And that's an acceptable way to leave it. You can leave it as y equals if you want, which might be handy for this question, but I'm not going to. I'm going to do it a different way. So question C, find the point of intersection between the median and the altitude. I've got two equations, y equals 3x minus 7. And I've got 2y minus x equals minus 19. Lots of ways to solve this. You could sub the y in for x here. You can make y here and then make them both equal, or you can do it like National 5 Maths. I'm going to do it like National 5 Maths because I've got a feeling a lot of us would. So I've got y minus 3x equals minus 7 for the first one, and 2y minus x equals minus 19. So I can just times the top one by 2, say, to get 2y minus 6x equals minus 14, and 2y minus x equals minus 19, and then just take away because the signs on the y are the same. Watch your signs here. Minus 6x minus minus x is minus 5x, and minus 14 minus minus becomes plus. So it's minus 14 add 19. 19 minus 14 is 5. So therefore x is minus 1, and then we just sub into one of our equations where we already had y equals 3x minus 7. So that's just 3 times minus 1 minus 7 minus 3 minus 7 is minus 10. Our point of intersection is minus 1 minus 10. And we're done there. This video is sponsored by Lecky, and they are offering viewers of this channel 30% off of any of their books. All you have to do is use the code CLERMONMaths, and the link to their books is down below. Now let's look at a couple of their books to highlight. We've got National 5 Maths and Higher Maths, And these are complete revision in practice. 2 books in one. We cover the whole course. Here's a random page, for instance, working simultaneous equations algebraically. You can see how good that book is and how clear it looks. But also at the end, practice exam papers that look exactly like the SQA exam papers that are published. Discount code Claire on Maths. Click the link to order now. SQA Higher Maths 2025 Paper 2 Question 2. Express 2x squared plus 16x plus 5 in px plus q squared plus r form, completing the square. So how this works is, you take 2 as a common factor of the first terms, x squared plus 16x, so that becomes 8x. Then you've got plus 5 hanging out, and you complete the square into x squared plus 8x, so that's x plus 4 all squared. Remember to take away 4 squared. But that's stuck inside this bracket, and the 5 is hanging out on the outside. So that's 2x plus 4 squared. And I'll have to do 2 16ths, which is 32, plus 5. So finally I get 2x plus 4 all squared, minus 32 plus 5 is minus 27. And we're done there. 2025, paper 2, question 3. The diagram shows the graph of y equals x squared minus 2x add 3. Calculate the shaded area. Shaded area, the integral between 2 and 4 of the graph then. So it's the integral between 2 and 4 of x squared minus 2x plus 3. dx. Integrate, so add 1 to the power, divide by the new power, minus 2x squared divided by 2 plus 3x between 2 and 4. Simplify, minus x squared plus 3x between 2 and 4, and then sub in. Now, you should just be subbing in, because if you don't show your sub in and then you mess it up, you might lose more marks. So always show your sub in, and then you get a mark at that position, minus a third, 2 cubed, minus 2 squared, plus 3 times 2. I mean, if you can't work out the rest, you're probably going to lose in 1 mark. So 4 cubed is 64 over 3. 4 squared is 16. 3 fours is 12. Minus 2 cubed is 8 over 3. 2 squared is 4. 3 twos is 6. Now, I usually like to work with that calculator as much as I can, just because I'm used to it. So 64 over 3 minus 16 plus 12 is minus 4. And then I've got minus 8 thirds. Minus 4 plus 6 is 2. And then I can take things out that bracket. 64 over 3 minus 8 thirds. Then I've got minus 4 still, then minus 2. 64 minus 8 is 56. So you get 56 thirds. And minus 4 minus 2 is minus 6. So that's 56 over 3 minus 18 over 3. 56 minus 18, well, that gives you 46, 38. So we get 38 over 3 unit squared. Or you can leave your answer as a mixed number if you really want to. SQA Higher Maths 2025, Paper 2, Question 4. The function g is defined as g of x is x minus 4 all cubed. Find the inverse function. There's 2 ways to do this. I'll show you both if you fancy. So the first method is the way I prefer nowadays, which is to say that g of g inverse of x equals x. So if you just sub in inverse of x, inverse function into x, you'll get it. So that gives me x becomes inverse function of x minus 4 all cubed equals x, I'm saying. So I need to get rid of that cubed, so I can say the inverse function of x minus 4 just equals the cube root of x, and then I've got it. Inverse function of x equals the cube root of x plus 4. And we're done there. Let me show you the alternative method. Alternative method is, let's start with our function again. G of x is x minus 4 cubed. You see, let y equal x minus 4 cubed, and then make y x the subject. So the cube root of y is x minus 4. The cube root of y plus 4 equals x. And then immediately you just say then inverse, it's not f, it's g in this case. The inverse function of x is the cube root of x plus 4. But be careful with this method. Don't ever change that to a y again, because you'll lose a mark. and you may need a statement at the start. I never use this method. I prefer this method nowadays. I think it's cleaner. SQA Higher Maths 2025, paper 2, question 5. Show that the points are collinear and then find the ratio that b divides a to c. So for collinearity, I do a to b, which is b minus a. So that is 6 minus minus 3, which is 9, minus 1 minus 2, which is minus 3, and 5 minus minus 1, which is 6. And then we do the same for b to c, which is c minus b. So that is 12 minus 6, which is 6, minus 3 minus minus 1, which is minus 2, and 9 minus 5 is 4. So we get 6, 2, 4, and 9 minus 3 and 6. So 6, 12, 18, 9, 18. The lowest common multiple between, say, 9 and 6 is 18. So if I just times that by 2, that equals that times 3, hopefully. So let's just check. 2ab hopefully equals 3bc. So they're multiples of each other. 9, 2 9s is 18, 2 3s is 6, and 2 6s is 12. 3 6s is 18, 3 2s is 6, 3 4s is 12. So we get the same. And therefore, we can then say that AB and C are parallel, but B is a common point. So AB and ABC are collinear. And now says state the ratio that B divides AC. Well, this is easy now. If you've written it like this, 2AB equals 3BC, then you just want AB over BC, and that's the fraction. Well, AB over BC is just 3 over 2, and that means that our ratio is simply 3 to 2. And we're done there. SQA Higher Maths 2025, paper 2, question 6. Express 5 cos x minus 9 sin x in the form k cos x plus a, where k is greater than 0 and a is between 0 and 2 pi. So we're working in radians because it mentions pi. And then solve 5 cos x minus 9 sin x equals 7 between 0 and 2 pi. Okay, so wave function first. 5 cos x minus 9 sin x equals k cos x cos a. Change the sign, k sin x sin a. So I'm now examining what's in front of cos x on both sides. Well, k cos a equals 5. And then similarly, in front of, say, sin x, well, it's minus k sin a, but it's a minus on both sides, so I can just cancel the minus straight away. So it's just k sin a is equal to 9. If you don't like that, you can just write minus k sin a equals minus 9, so k sin a equals 9. So we've got our two equations. To get our k, it's just Pythagoras. K is the square root of both the numbers squared and added. So that is 25 and 81. 81 becomes 86, 96, 106. So I've got my k. Tan A is sine over cos 9 over 5. So I do the inverse tan of 9 over 5 in my calculator, making sure my angle is in radians. Radians inverse tan 9 over 5 is 1.063697. So I think 1.064 is a reasonable place to stop. Check that it is actually A with a cast. I never skip this step. The sine equation was positive and the cost equation was positive, so A is 1.064. So that means A equals 1.064. So we've got root 106 cos x plus 1.064. And we're done there for part A. B says, hence solve 5 cos x minus 9 sin x equals 7 between 0 and 2 pi. Well, it's the same equation, so I just make that equal to 7. Root 106 cos x plus 1.064 equals 7. So divide by the root 106. And now do my inverse cos of 7 over root 106. As if it just says x, really. So again, make sure my calculator's in radians. Shift cos 7 over root 106 is 0.823. Cast diagram to get another answer before I take off the 1.064. So cos was positive. So I do 2 pi minus the answer. So I can do 2 pi minus 0.823. 2 pi minus 0.823 is 5.460. So two answers to start with, but they're not my answers. It's got x plus 1.064. So I say x plus 1.064 equals 0.823. X plus 1.064 equals 5.460. Solving that, x would be, not doing the sums in my head, 0.823 plus, minus 1.064 is 0.241, but we are minus. Now the answers are between 0 and 2 pi. So if you ever get outside that range, you just add multiples of 2 pi. So I'm just going to add 2 pi because I'm outside the range. And that'll get me inside the range of 6.042. By adding 2 pi, I get 6.042 for the first one. Doing the same for the next one, we've got 5.460 minus 1.064. That's 4.396. Now that is within the range. Pi is about 3.14, 2 pi is 6.28, 4.396 is nice in there. Now I've not got multiple angles here like 2x or 3x, so I know I'm going to be done. So that's it. I've done my answers all right. I'm out nice and neat. X equals 4.396 and 6.042. And we're done there. SQA Higher Maths 2025, Paper 2, Question 7. Integrate 3x plus 2 to the power of 7. All right, so this is the chain rule. 3x plus 2 to the power of 7. I add 1 to the power is 8. I divide by the new power, 8. But you also divide by whatever's inside that bracket differentiated. You need to break the chain. 3x plus 2, differentiate it is 3. So there we are there. And then we've got plus c, of course. Don't forget your c. That's 3x plus 2 to the 8. 3x is 24, so I'll just write it as 1 over 24 for neatness, plus c, and we're done there. SQA Higher Maths 2025, Paper 2, Question 8. EABCD is a rectangular base prism with AD is shown, DC and DE. Find B to E in terms of IJK. So B to E, where's B? There it is. So I need to get all the way to E. So I could go along here. That seems reasonable. So B to C, which is the same as A to D. So let me write that down, 6, 4, 2. I always work in component form and change back. And then I need to go along here, which is the opposite direction of D to C. So minus 2, minus 4, and 2. And then I need to go up here to get to E, which is the same direction as D to E. So plus again, minus 4, minus 3, 4. So work out my numbers. 6 minus 2 is 4. Minus 4 again is 0. 4 minus minus 4 is 8. 8 minus 3 is 5. 2 minus 2 is 0, plus 4 is 4. So in IJK form, I've got 0i plus 5j plus 4k, which you can just write as 5j plus 4k. And you're done there. SQA Higher Maths 2025, Paper 2, Question 9. A sequence satisfies the recurrence relationship un plus 1 equals mun plus 4, and m is a constant. The sequence approaches a limit as 10 as n goes to infinity to determine the value. I'm still going to save it. The limit exists implies that minus 1 is less than m is less than 1. I'm going to work at my m anyway. And then we've got L equals B over 1 minus A. So B is 4, 1 minus M, and that equals 10, it says. So solving that equation, 10, 1 minus M equals 4. That's 10 minus 10M equals 4. So minus 10M equals 4 minus 10, which is minus 6. So M is minus 6 over minus 10. Simplify that, minuses disappear, minuses cancel, then we divide by 2. 6 divided by 2 is 3, 10 divided by 2 is 5. So there's our M. Part B, U1 is 19, find U0. So UN plus 1 equals 3/5 UN plus 4. And U1 equals 19. So we can just say that if we had U1 here, it would give me U2. If I've got U1 here, it will give me U0 here. So we can just say that 3/5 U0 plus 4 equals U1, which is 19. So 3/5 U0 equals 15. So 3U0, U0 is 75, 5/15. So U0 is 75 over 3, which is 25. And we're done there. SQA High Maths 2025 Paper 2 Question 10. A hotel owner is design and shown, signs shown with room numbers. There's the sign. Each sign is a rectangle, right angle above it. The length and breadth is 5x. And y, we've got 5x and y, and the shorter sides of a triangle are 3x plus 4x. And obviously it's a right angle. It shows that the perimeter is given by that. So let's have a look and work on this. It also tells us that the area of the sign is 150. So let's start off with something for our perimeter. Our perimeter is all the way around. So I need to go y plus 5x plus y plus 5x plus y plus, well, just 3x and 4x. So that equals 5, 6, 7, 8, 9, 10, 11, 12x plus 2y's. So I need to get rid of that y somehow. It says the area of the sign is 150. So area is 150. Well, what is the area? It's base times length, or base times height, 5xy, plus, now this is a right angle triangle, so it's just half the base times the height to get the area of that. Half the base would be 2x times 3x. I'll write that out, half the base times the height. So that's 5xy plus a half of 4 is 2 times 3 is 6. And x times x is x squared. But that equals, remember, 150. And my perimeter in the question doesn't have a y, so I make y the subject. So 5xy equals 150 minus 6x squared. So making y the subject, y is 150 minus 6x squared over 5x. So we can write our perimeter as 12x plus 2y is 12x plus 2 times 150 minus 6x squared over 5x. So what's that? 12x. 150 divided by 5 is 30 times 2 is 60. But then there's an x on the bottom. So then another one, 2 6's is 12. So that's minus 12 over 5. But then the x will be an x squared over x. So that's just x on the top. So working that bit out, 12x minus 12x over 5 plus 60 over x. Now it had a decimal answer, so I'll just work it as a decimal. 12 minus 12 over 5. That's 9.6. So our perimeter is 9.6x plus 60 over x as required. But if you couldn't do that, you should have just moved on and skipped it, because you can do part B. Each sign will be using a lightning strip placed around its perimeter. The hotel owner requires the perimeter of the sign to be as small as possible. Find the minimum value of P. Optimization, differentiation. So part B, minimize this then. So stationary points occur when P dash equals 0. So P dash, well, I'm going to have to get ready to differentiate first actually. So P equals 9.6x plus 60x to the minus 1. So P dash is going to be 9.6 minus 60 x to the minus 2, and that's going to equal 0. So there's a few ways to solve this, but what I usually like to do is just say that that's minus 60 over x squared. And then just times both sides by x squared. So that gives me 9.6 x squared here, minus 60 x squared over x squared, so it's gone, equals 0 x squared. And then I can solve that. 9.6 x squared equals 60. So x squared is 60 over 9.6. So x is the square root of 60 over 9.6. And I'm pretty sure the question told you that x would be greater than 0. It has to be anyway. Does it say anything about it? It doesn't, but once we square root that, we can't have a negative x because you can't have a negative length. So that will just be a positive. Which is 2.5, because x cannot be minus 2.5. Okay, so it is 2.5, and then we have to minimize the perimeter, so we actually have to sub that back in. But before we do that, we need to do a nature table to check that it's a minimum. Along to 2.5 and along, P dash, just pick 2 and 3, say. So subbing in 2, we get 9.6 minus 60 over 2 twos is 4. Well, that's a negative number. That's 0. And when we sub in 3, you get 9.6 minus 60 over 3 threes is 9, which is a positive number. So that goes down, along and up, and therefore x equals 2.5 is a minimum TP. So x equals 2.5 minimizes the perimeter. What a perimeter was? A perimeter was 9.6x plus 60 over x. 9.6x plus 60 over x. So that's 9.6 times 2.5 plus 60 over 2.5. 9.6 times 2.5 plus 60 over 2.5 is 48. So our minimized perimeter is 48. And I'm pretty sure our units were centimetres or metres. Let's have a look. Centimetres, I think. And we're done there. SQA High Maths 2025, Paper 2, Question 12. Solve 3 sine 2x plus 4 cos x equals 0. So 3 sine 2x, that's just 2 sine x cos x from the start of the exam paper, plus 4 cos x equals 0. And it's just between 0 and 360. So 6 sine x cos x plus 4 cos x equals 0. Common factor then, 2 cos x, 2 times 3 sine x, and then 2 twos is 4, equals 0. So we get 2 cos x equals 0 and 3 sine x plus 2 equals 0. So that gives me cos x equals 0 on this side and sine x equals negative 2/3. And we're working in degrees here. So cos x equals 0. If you're not sure, by the way, you have got a calculator. Inverse cos of 0 is 90. So we get x equals 90 here, and then it happens again at 270. So there's our first two answers. And then for this one, I'll do the inverse sine of 2/3, never in the negative. Shift sine 2 over 3 is 41.8. Cast diagram. Sine was negative, so we want to pick T and C. So our x for the sine one is 180 plus 41.8 and 360 minus 41.8. Two answers, and you can use a calculator to work them out. So let's just do that. 180 plus 41.8 is 221.8, and 360 minus 41.8 is 318.2. So there's our two answers. And we're done there. We've got all 4 answers. You can write them out in a line if you want, just to be neat. 90, 270, 221.8, and 318.2 degrees, all degrees. And we're done there. SQA Higher Maths 2025, Paper 2, Question 12. Functions f and g are defined as a set of real numbers by that. Find an expression for h of x, which is f of g of x. Okay, part A, f of g of x means in f, put in g every time you see an x. So f says x to the power of 5. So that is g of x to the power of 5 plus 3. What is g of x? 1 minus x cubed. So I put 1 minus x cubed here. That's to the power of 5 plus 3. There's not much else I can do with that because it's spanning a fifth bracket beyond us. So we've got 1 minus x cubed to the power of 5 plus 3. Now part B says find h dash x. So it's differentiation then. Well, chain rule. 5 comes down to the front. 1 minus x cubed stays where it is, and I take away 4. The 3 is going to disappear, of course. And now I need to break the chain. 1 minus x cubed, I need to differentiate it. So x cubed becomes 3x squared, and it's a minus. So it's times by that. 5 3s is 15, so minus 15x squared. 1 minus x cubed to the power of 4. And we're done there. SQA Higher Maths 2025, Paper 2, Question 13. A radioactive substance has been collected, decays over time, and the mass is given by m equals 150 e to the minus 0.0054 t, where m is the mass and t is the years after the radioactive substance is collected. Find the initial mass of the substance. Initial means t equals 0, so m equals 150 e to the minus 0.0054 times 0. That's 150 e to the 0. Well, e to the 0 is just 1, so that's 150. It says it's in micrograms, I think. Yeah, so I'll just write micrograms to be on the safe side. And we're done there. Part B says, calculate the time taken for the mass of the substance to decay to 120. So m is 120. So I'll just write 120 equals 150 e to the minus 0.0054 t. That becomes a fraction. That stays there, e there. I will simplify the fraction. So that's 12 over 15. And 3 goes into 12 4 times, and 3 goes into 15 5 times. Take the log of both sides now, because I've got my t in the power position. So ln 4/5 equals ln e to the minus 0.0054 t. That means I can take my 0.0054 t to the front. So ln 4/5 equals minus 0.0054 t ln e. But ln e, remember, log e is 1. So that means I can work out my t is just ln of 4/5 all divided by minus 0.0054. Get your calculator. ln bracket, I've already got a bracket, 4 over 5 equals that. I'll press then divide, minus 0.0054, 41.32 roughly. And it was in years. And we're done there. SQA Higher Maths 2025, Paper 2, Question 14. This was a doozy, this one. I think a lot of people found this hard, so let's get into it. Circle C1 has equation x plus 5 squared plus y minus 6 squared equals 9. Find the centre and the radius. Okay, so the centre is easy enough of C1. That's just x plus 5, so minus 5, y minus 6, so plus 6. And then the radius is the square root of 9, which is 3. So nothing major there. C2, that's radius as well. So minus g minus f. So 2g is 14, well, minus. So g is minus 7. 2f is 6, so f is 3. So it's minus g minus f, 7 minus 3. The radius is the square root of 7 squared plus minus 3 squared minus the 54 in the end. This is just all from the start of the exam paper, of course. 7 sevens is 49, 3 threes is 9. 7 sevens is 49 and 3 threes is 9. Minus 54 is 4, so the radius of that one is 2. So R2 is 2. We'll call that R1. And we're done there. We'll get to part C now. C says, circles C1, C2, C3 are touching as shown in the diagram. The centre of C3 lies on the line joining the centre of C1 and C2. Determine the equation of C3. And I think this is where a lot of us will go, what do I do with this? This is the last question of the paper. It is designed to be difficult, okay? So don't worry too much. But let's see what we already know. R1 was 3, remember, and R2 is 2, and C1 was minus 5, 6, and C2 was 7 minus 3. So we've got all that information to start with. So let's just shove some stuff on here. I need the centre and I need the radius of this, okay? So the first thing I'm going to do is try and work out the radius by looking at the distance between C1 and C2, because I've got two centres. So the distance of C1 to C2, distance formula of Pythagoras, you've got 7 and minus 5, the difference between them is 12. And then you've got 6 and minus 3, the difference between them is 9. 7 minus 5 is 12, minus 3 minus 6 is 9. 12 squared plus 9 squared is 225, which square roots to 15. You check out yourself, I just know that one. So we know that the radius, the distance between centres is 15. So how does that help me get the radius, you might be wondering? I've worked out my distance between the centres, so I now know that this whole line here is 15. So how am I going to get my radius? Well, I know nothing about this bit. But what I can do is I can say, well, look, what if I tried to go for the diameter? If I went all the way along here, I would have the distance plus an extra 3, but then I would be that many too far, so I'd have to take away 2. So it's the whole distance between the centres plus the 3 take away the 2. So the diameter is 3 plus 15 take away 2, which is 15, 16, 17, 18, minus 2 is 16. So the radius C3 is half of that, which is 8. So I've got one bit of the information now. This whole line, we know that now that this bit's 8, and then we've got 2 extra, so that's 10. And what about the other side of that line? Well, we've got 3 to this point, and we know that the radius of this thing here is, well, the distance between centres is 15, so that must be 5. So it must be 5 and 10. So I'm going to draw that out on a straight line for you. If I just draw it as like this, and it's C1 there, C3 somewhere, and C5, since we know the whole line is 15, and since we know the distance between here and here is 10, then we know the distance between here and here must be 5, because the distance between the centres is 15. So now that we've got that, we can just use vectors to work out our centre. Now you can use the section formula, but I don't like the section formula. So I'm just going to use vectors. C1 was minus 5, 6. And C2, sorry, was 7 minus 3. And I want to work out this one. So let's call that x, y, z for the sake of it. Then I know that if that's 5 to 10 as a ratio, I can simplify that to 1 to 2. So far, so good. So x to y over y to z equals 1 to 2, 1 over 2. That's what I'm thinking about. So that means that y to z equals 2xy. So y to z is y to z is z minus y equals 2 y minus x. And I'm trying to get y because that's what I've called a middle point or vector. So z minus y equals 2y minus 2x. So if I take the y over here, I get 3y, and I get z plus 2x. So finally, y is z plus 2x over 3, or a third of z plus 2x. Well, we've got z and x. Z is 7 minus 3, plus 2 of x. X is minus 5, 6, so that's minus 10, 12. That's a third. 7 minus 10 is minus 3. Minus 3 plus 12 is 9. A third of that is minus 1, 3. So that means that our point centre, C3 we're calling it, is minus 1, 3. And we know its radius now already, way back up here. I think we worked out that it was 8. So we need to know the equation then. X minus minus 1 plus 1 squared plus y minus 3 squared equals 64. And finally, we're done there. This has been Clever Maths, and today we did SQA Higher Maths 2025 Paper 2. Hopefully you found that useful. Take care, stay safe, and goodbye.